Welcome all of you. So today we have start our unit 4 for software in architecture and design. Okay. So uh, our fourth unit is design pattern and catalog. Okay. So what is the design? The design means the architectural phase. Okay. So this phase we have to study in the SDLC. Okay. Software designing and architecture. Okay. So as per the client requirement, okay, as per the client requirement, the designer design the particular model of the software. Okay, so in software conclude of the number of the modules. Okay, so what is design? So design pattern represent the best practices used by the experienced object oriented software developer. Okay, so what they say in object oriented means whatever the any software contain the number of the object means the module. Okay, and each and every module having that's functionality or the responsibility about that particular software. Okay, so design pattern are the solution to the general problem that software develop face during the software at the development. Okay, so whatever whenever the software developer develop the particular software, that time what they say that software developer getting the solution. Okay, solution from the design pattern how to develop the particular software. Okay, so this solution were obtained by the trial and error by the numerous software developer. Okay, so then what they say, what is the gang of the four? Okay, so it is called as GOF. Okay, gang of the four. So in 1994, so these are the four author. Okay, these are the four author, that is Erich Gamma, Richard Helm, Ralph Johnson, and John uh, Wilsids published a book of titled Design Pattern Elements of the Reusable Object Oriented Software. Okay, so these particular books is published by, okay, this published by or the right by these four authors. Okay, which four authors? That are Erich Gamma, Richard Helm, Ralph Johnson, and Johann Wilsde. Okay, so what they say, which initiate the concept of the design pattern in the software development. Okay, so these four author only focus on the designing of the software developer. Okay, so why the design is important? Because to develop any software project we have to require to conclude the number of the models for each object. Okay, number of the modules for each object, and each module having their own responsibility. Okay, so design pattern is the most important. So this concept was right this co-author. Okay, in the book of the design pattern element of reusable object oriented software. Okay, then these authors are collectively known as the Gang of the Four. Okay, so Gang of the Four means four author. Okay, accordingly to these author, design pattern are the primary based on the following principle. Okay, principle of the object oriented design. Okay, so which of the principles? So the first principle, okay, program to an interface, not an implementation. Okay, and then the second principle is the power object composition over inheritance. Okay, so these are the means the interface and the inheritance. Okay, so these are the concept. Okay, or these concept are including in these two principles. Okay, then we turn toward the uses of the design pattern. Okay, why it is used? Because this author say these are the important part. Okay, so we seen that why it is used, because design pattern have two main usage in the software development. Okay, so these are the two main uses. Okay, so the first use, okay, what is first use? Common platform for the developer. Okay, so design patterns provide a standard terminology and are specific to the particular scenario. Okay, so what they say, they say that whenever the designs means the design the software. Okay, software designing. So we can say that whenever the developing of the any software, that time we have must require the modules. Okay, so these particular modules are designs. Okay, for example, what they say, a singleton design. Okay, what they say, singleton means the only single object. Okay, only single object in the particular model. Hence, it is called as single tone design pattern. Specify the use of the single object. All developer familiar with the single design pattern will make the use of the single object, and they can be tell each other program is the following a singleton pattern. Okay, do you understand? Okay, what they say only singleton means at the design pattern specifies only a single object. Okay, only a single object. For all developers are the familiar with the single design pattern because it used to the simply uses. Okay, so it is not complicated because we only use a single object in that particular design pattern. Okay, which design pattern? Single tone design pattern. Okay, then another one is the best practices. Okay, design pattern have been evolved over a long period of the time, and they provide the best solution. Okay, so this is the main use of the design. Okay, long period of the time. Okay, designing phase is the long period of the time, but it will provide, okay, it will provide the best solution whenever developer develop the particular software. Okay, so what software developer do, he get the answer. Okay, he get the solution to the certain problem whenever during the software development. Okay, uh, so he getting the answer or he getting the solution from the designing pattern. Okay, from the design pattern. So the learning of this pattern help the unexperienced developer to learn the software design easy and faster way. Okay, so because what, so this is the advantage of the learning software. Okay, learning software or to learn the software to the unexperienced developer. Okay, so what, designing phase. Okay, so then we to turn toward the types of the design patterns. Okay, so which are the types? So as per the design pattern reference book. Okay, so this is the reference book. So design pattern element of the reusable object oriented software. Okay, so this book is authored by the, what we can say, G Goff. Okay, gang of four. Okay, so there are the 23 design pattern. Okay, how many? 23 design patterns which can be classified into the three categories. Okay, how many design pattern? 23 design pattern. So we are classified this 23 design classified into the three categories. So the first category is the creation. Okay, second one is the structural, and last one is the behavioral patterns. Okay, so what is the creation pattern? Okay, so they say that this design pattern provide a way to create the object. Okay, uh, creational means the creating the object now. So meaning we can find out only this word, what, creational pattern. Okay, so this design pattern provide the way to create the object while hiding the creation logic rather than the instantiating objects directly using the new operator. Okay, this gives the problem more flexibility in deciding which object need to be created for given use case. Okay, so what they say, they say that the creating object, okay, only show the creation of the object, but hiding, okay, what hiding? But hiding the logic, okay, logic hiding. Then another one is structural pattern. Okay, so what is structural pattern? So uh, the design pattern concern class object compositions. Okay, what class of, so we can say that structural pattern means the particular structure na. So the particular structure we can be defined into the class and object type. Okay, object decomposition type, because whenever we have to develop any software, this software is decomposed into the number of the module. Okay, so this is the structural way. Okay, this is the structural way, so we can say that this is the structural patterns. Okay, so the concept of inheritance. Okay, inheritance means the one class is inherited from its parent class. Okay, child class is inherited from its parent class, so this is the actual structure na. Okay, so is used to decompose interface and define way to compose the object to obtain the new functionality. Okay, so what they say, so the inheritance property, so the functionality of the parent, whatever the parent class is used to is use to derive the functionality for the child class also. Okay, so they say that the decomposition of the object, okay, decomposition or the composition of the object to obtain the new functionality. Okay, then the third one is the behavioral pattern. Okay, behavioral pattern means these patterns are the specifically concerned with the communication between the object. Okay, so what we have to see at the previous some lecture, because here are the number of the object. Okay, but these objects are the functionally depend upon the each other. Okay, so they having some relationship between them. Okay, some between them, so we have say that it is the communication between the object also, so this is the behavioral pattern. Okay, then we move toward the design pattern, so that is the uh, point is the factory pattern. Okay, so what is factory pattern? Okay, so the factory pattern is the one of the most used design pattern in the Java. Okay, where it is used? So it is used in the Java. This type of the design patterns come under the creational patterns, as the patterns providing the one of the best way to create object. Okay, so creational pattern. Okay, this particular factory pattern is come under the creational patterns. Okay, because he create an object now, he create the object, so we can say that he it is comes under the creational pattern. So what they say, in factory pattern we create the object without exposing the creation of logic to the client, and refer to the newly created uh, object using the common interface. Okay, so they can say that the creation of only the logic. Okay, so this is the without exposing. Okay, without exposing the creation of the logic. Okay, so it is comes under the creational patterns. Okay, so this is the factory patterns. Okay, so this is the implementation of the factory patterns, how we can implement the factory patterns. Okay, so these are the designs patterns. Okay, so we going to create a shape interface to concrete classes implementing the shape interface. Okay, so here is the a factory class is the shape factory. Okay, is defined as in the next step. So what they say, the factory pattern demo, so our, so this is the demo. Okay, this is the example. So our demo class will be same factory to get the shape object. Okay, it will be pass information. Okay, pass information, so these are the shapes now. These are the shapes, circle, rectangle, square. Okay, so we have to require to create that shape. Okay, so we can say that this is factory patterns is come under the creational patterns also. Okay, so to the shape factory to get the type of the object is needs. Okay, so these are the types of the object, which are the circle, rectangle, and the squares. Okay, then so this is the actually patterns. Okay, factory pattern. So this is the shape. Okay, this is the shape. Then the here is the interface. So this is the class diagram. Now this is the class diagram. So the implementation. Okay, implementation. What is the class including in the circle, square, and the rectangle. Okay, circle, square, and then the functionality, that is the draw. Okay, that is the draw, and whatever the draw, the creation of the object. Okay, it is the one object. It is the one object, and it is the one object. Okay, so this is the factory pattern. Okay, so factory pattern demo. So there is the functionality, main functionality. Okay, and ask. Okay, ask shape factory, shape factory gate shape. Okay, so this is the functional, this is the function. Okay, which is function gate shape. Okay, gate shape, and it will call to create. Okay, it will call to create. These are the functionality. Okay, these are the two, it is called to create the object. Okay, so this is the first object, second object, and the third object, and last one is the draw the shape. Okay, draw the shape. So you can be see from here. Okay, factory pattern demo. Okay, so what is factory pattern? So you can say that it is come under the creational patterns. Okay, so what is creational? So create any object. Okay, create any object. So it is the demo. What they say that the creation of this object. Okay, circle, square, and rectangle. Okay, and these are the function. Draw whatever the void, draw void. Okay, so draw this square, draw this circle, draw this rectangle. Okay, so this is the shape, whatever you can say that factory pattern. Okay, then we turn toward the another pattern. Okay, we turn toward our another design pattern, that is the abstract factory pattern. Okay, so what is abstract? So abstract factory patterns work around the super factory which create the other factories. Okay, so what they say, the super factory. Okay, and we create the other factory, means the factory is also be called as the factory of the factories. Okay, so this particular pattern consist of the number of the factories. Okay, number of the factories. So the this type of the design patterns also becomes under the creational patterns. Okay, because in this particular patterns, abstract factory patterns comes under the another factories na, another factories, and the factories patterns is also comes under the creational pattern. So we can say that this also be the abstract factory patterns is also comes under the creational pattern factor. Okay, as this pattern provide the one of the best way to create and the object. Okay, so in abstract factory pattern, what they say is an interface is responsible for creating factory of the related object. Okay, related object. So whatever any software design, we can say that number of the objects are the related functionally related with each other. So they can say that in this particular factory, means it is the abstract factory na, this is the abstract factory. So we can say that the factory comes under the factory or the super factory. Okay, so we can say that here are the number of the object. Okay, here are the number of the objects. So each generated factory is due to the object per factory patterns. Okay, so then we move toward the implementation of the abstract factory, okay, abstract factory pattern. So we are going to create a shape interface and concrete class implementing it. Okay, so how we can implement this particular factory? So we know now what is abstract factory, okay, because the factory in factory or the super factory, okay, so the factory class shape factory is defined, okay, so this is also be the example of the shape factory, okay, which extend the abstract factory, a factory creator generator class factory or the producer is the created, okay, then the this is the example what abstract factory design, okay, abstract factory pattern demo, okay, so this is abstract factory pattern demo, okay, so this is the main function, okay, this is the main function and the uses what a factory producer and the abstract factory also, okay, so what is abstract factory? So the factory is in factory, okay, so these are the two factory, okay, shape factory and the rounded shape factory, okay, so these are the two factory, okay, these are the two factory. So these two factories are comes under the this factory, okay, abstract factory, get it now, this comes under the this abstract factory because these are the two factories, okay, so in this particular class diagram they can say that create shape and this is the common functionality, okay, this is the common functionality, that is the drawing whatever the void, okay, then what are the object? Rectangle, square, rounded rectangle, and the rounded square. So what we can say that these particular objects are related with each other. Okay. What I am say that these objects are the related with each other. Means I say that this rectangle is also be the shape. This square is also be the shape. Rounded rectangle is also be the shape, and rounded square is also be the shape, means this is the relation, okay, and the functionality is the drawing functionality, okay, functionality is also be the same, okay, functionality is also be the same because rectangle have also be the draw, square is also be the draw, rounded rectangle is also be the draw, and rounded square is also be the draw, hence we can say that these four objects are related with each other, okay. So for this particular functionality, and these are the two factories, okay, so first factory is the step factory, second factory is the rounded shape factory, and these two factories are comes under the abstract factory, okay, comes under the abstract factory, okay, get it, so this is also be the very simple, okay, then we move toward the another design patterns, okay, so all of you get it what is single tone pattern, okay, single tone pattern, so the single tone pattern is the one of the simplest design pattern in the Java, okay, so why it is simplest? Because in this type of the design patterns comes under the only one object, okay, creation of only one object, hence we say that it is the single tone pattern, okay, hence we say that it is the single tone pattern. Then in this pattern involve a single class which is responsible to create an object while the making sure that only a single object is get created, okay, so you remember it what only object get created, only single get created, okay, in this class provide a way to access its only object which can be accessed directly without need to instantiate of that object of the class, okay, so this is the single tone patterns, okay, this is also we say that this is the very simplest design pattern in the Java. Why it is simplest? Because it comes under the creational pattern also, okay, it comes under the creational patterns also, and it will provide the it will provide the best way to create a single object. Okay, to create a single object. So this is the template design pattern in the Java. Okay, then we move toward the implementation of the single object, whatever the single tone pattern. Okay, so the implementation. Okay, so what is in this particular patterns only the single object now, so we are going to create the single object class. Okay, whatever what is the class or the in class diagram here is only the single object class also. Okay, so the single object class also have its constructor as provide a private and have to static instance of itself. Okay, then single object class provide a static method to get a static instance to the outside of the world. Okay, so the single patterns demo. So this is the example. Okay, so you can understand what is single tone patterns. Okay, so this is the single tone patterns. Only one object. Okay, creation of only one object. Okay, so you can get from only the title single tone patterns. Okay, means only the creation of the single object. Okay, creation of the single object, so we can say that it is the very simple pattern in the Java. Okay, so single pattern demo. Okay, then this is the main functionality. Okay, this is the main functionality, and this is the creation. Okay, creation of the object means only the single object. So this is the class. Okay, this is the class, so the instance single object, and these are the functions. Okay, single class object, so get instance single object, show message, void. Okay, and this is the return. So these are the loop or the functionality. So you can say that this is the single tone pattern. Okay, this is the single tone pattern. Okay, then we move toward the another pattern. Okay, another design pattern, that is adapter pattern. Okay, so from this word what you have to think about the adapter. Okay, so what is the work of the adapter? So adapter pattern work as the bridge between two incompatible interface. Okay, so what they say, adapters, you also be use the adapter now. Okay, you also be use the adapter. So these type of the design patterns come under the structural patterns. Okay, so this adapter patterns is comes under the structural patterns. Okay, so as these patterns combine the capability of the two independent interface. Okay, two independent interface means the adapter. Okay, means the adaptation. You also be use adapter by to insert the memory card, and adapter you can be insert into your laptop also. So what they say, adapter means the bridge between two incompatible interfaces. Okay, so you can't be use memory card directly to your laptop now, so you have required the adapter. Okay, you have required the adapter. Okay, so these patterns involve a single class which is responsible to join the functionality of the independent or the incompatible interfaces. Okay, independent or the incompatible interface. So what they say, this is the example. Okay, a real life example could be case of the card reader. Okay, card reader, so which is act as an adapter between the memory card and the laptop also. So I am as per the previous, I am say that what the card reader. Okay, which act as the adapter between the memory card and the laptop. So you plug in the memory card into the reader. Okay, you plug in the memory card into the card reader and card reader into the laptop. Okay, so wow, what is the action of the card reader? Okay, so the action of card reader is the adapter. Okay, is the adapter. So we are the demonstrating the use of adapter pattern via the following. So this is the example. Okay, what which is the audio player device can be MP3 file only and want to be used to advanced audio player capable of playing VLC and the MP4 file. Okay, so this is the example. Okay, then implementation. Okay, then we move toward the implementation of the adapter pattern. Okay, so what they say that we have a multimedia or the media player interface. Okay, and a concrete class audio player is the implementing. Okay, the media player is the interface. Okay, so what they say, audio player can be play mp3 format audio files by default. Okay, then we are having another interface. Okay, that is advanced media player concrete classes implementing the advanced media player interfaces. Okay, so these classes can be play VLC and MP4 format files. Means what they say that audio player only can play the MP3 format audio. Okay, but advanced media player interface. Okay, so this is the interface. Now what is interface? Advanced media player. Okay, so these classes can be play VLC and the MP4 files. Okay, but audio player is cannot be play the VLC and MP4 files. Okay, then what they say, we want to make the audio player to play the other format as well. Okay, so attain this we have to create an adapter class. Okay, what they say, we have to create an adapter class media adapter which implement the media player interface and uses the advanced media player object to play the required format. Okay, so what they say, in media player, so this is the audio player. Okay, audio player. So what they say, so we have required the interface now to play the VLC and MP4 format files also. Okay, so what they say that they only the create. Okay, so what they create, so they create for the audio player. So this is the format now. So they say that we create the adapter class. Okay, what adapter class? Media adapter. Okay, so this is the adapter class which implement the media player interface. Okay, what they say, so this class media adapter create the media player interface and uses the advanced media player object to play the required format. Okay, so this is the adapter. Okay, so audio player uses the adapter class media adapter, passing it to desired audio type without knowing the actual class and which can the desired format as the adapter pattern demo. Okay, so our demo class will be use the audio player class to play the various format. Okay, so you can see here. Okay, how it will, this is the structural. Okay, so this is the advanced media player. Okay, what is this advanced media player? So the functionality of advanced media player is the play VLC and the play MP4. Okay, play VLC and the play MP4. But here is the audio player. Okay, audio player, it is only play the mp3. Okay, mp3 audio, but not play the mp4 and the vlc also. Okay, so it uses the adapter class. Okay, adapter class means which adapter? Media adapter. Okay, which adapter? Media adapter, and uses this audio player, this particular media adapter, and play the all types of the um, audio. Okay, audio or the video also. Okay, so this is the demo of the adapter pattern. Okay, so this is the demo. Then audio player is the initial. Okay, and the media adapter. Okay, media adapter is the what we can say that media player is also play the important role as the media adapter to connect these two interface. Okay, which two interface? Audio player and the advanced media player. Okay, so these are the two interface. Okay, get it now? So this is the simple. So by using this particular advanced media player, audio player uses this advanced media player, and he can play the VLC MP4 audio or video also. Okay, get it? So this is the very simple. Okay, this is the structural diagram. Then we move toward the another design pattern. Okay, so another design pattern is the facade pattern. Okay, so facade patterns hide the complexity of the systems. Okay, so what they say, it hide the complexity. Okay, it hide the complexity of the system and provide an interface to the client using which the client screen and the systems. Okay, so what they say that he these particular patterns hide the complexity of the system. Okay, so this type of the design patterns come under the structural patterns. Okay, so these are the two patterns are comes under the structural pattern. So the first pattern is your adapter pattern, and the second pattern is the facade pattern. Okay, so these also becomes under the structural patterns. Okay, so these patterns add the interface to the existing system to hide its complexity. Okay, so what they say, he provide the interface. Okay, he provide the interface to the system. Okay, so this pattern involve a single class. Okay, then what they say, single class which provide the simplified method by using the client and the delegate calls to the method of the existing system. Okay, then we move toward the implementation. Okay, what is the actual functionality of the facade pattern? Is to reduce the complexity. Okay, is to reduce the complexity and to provide the interface to the existing system. Okay, to hide the complexity of the system. Then the implementation. Okay, so we are going to create a shape interface. Okay, and the concrete classes to interface the shape interface. Okay, so this particular class shape maker is defined as the next shape. Then we move toward the actual demonstration. Okay, so shape maker class uses the concrete class to delegate the user calls to these classes. This is packet pattern demo. So our demo class will be a shape maker class to show the result. Okay, so what is result? So you can see in the diagram. Okay, so what they say that the particular packet pattern provide the interface. Okay, provide the interface to the system na, and reduce the complexity. So this is the packet pattern demo, and this is the main functionality. Okay, so this is the main class. Okay, this is the main class. Then the shape maker. So what is shape maker? So shape maker is the interface. Okay, this is the interface. Shape maker is the interface. So what they say, it provide the functionality. It provide the interface to the system na, and hide the complexity. So this is shape maker. So circle, that are the shape, or these are the objects. Okay, these are the objects. So we only say that it provide the interface. Okay, interface to the system. So this is the system. Okay, this is the all system, and it will be provide the interface to the system also. So these are the three object. Okay, these are the three object, and by using this particular interface, system can be draw this particular object also. Okay, system can draw this particular object or this particular shapes also. So these are the three objects: circle, rectangle, and the square. Okay, so these are the uh, facade pattern. Okay, then we move toward the another pattern. Okay, So another pattern, that is the proxy pattern. Okay. So the what is the proxy pattern? So you can be say that in proxy pattern, a class represent the functionality of the another class. Okay. So what they say, the class represent the functionality. Okay. Functionality of another class. So this type of the design patterns come under the structural pattern. So what we can say that structural pattern mean the particular structure like interface. Okay, like interface. Okay, or the inheritance. Okay, inheritance means what we can say that the functionality can be transferred from the parent class to the child class, means the actual structural. Okay, so in proxy patterns we create the object having the original object to interface its functionality to the outer world. Okay, so what they say that we create the object. Okay, this particular patterns create the object, and this particular object is the functionality to outer the word. Okay, so what this particular class is represent the functionality of the another class also. Okay, or the outer word also. Okay, so this is the proxy pattern. Okay, what is proxy pattern? So proxy pattern is the class represent the functionality of the another class. Okay, then implementation. Okay, so the implementation of this particular patterns having, so we are going to create the image interface. Okay, and to concrete classes implementing the image interface. So the proxy image is the proxy class to reduce the memory footprint or the real image object loading. Okay, so this is the implementation part. Okay, so what is implementing the image interface? Okay, the image interface, and what they say that the proxy image. Okay, proxy image is the proxy class. Okay, what is your proxy class? Your proxy image. Okay, proxy image is your proxy class. It reduces the memory footprint of the real image object loading. So this is the demonstration. Okay, so the proxy pattern demo, our demo class will use the proxy image. Okay, so this is the proxy image to get the image object to load and display as it need. Okay, then this is the structural pattern. Okay, this is the structure. So these are the class. Okay, these are the class. Then this is the proxy pattern demo. Okay, so what we can say that the object is represent the functionality of the another object. Okay, functionality of the another object. So this is the proxy image, means your proxy class. Okay, means your proxy class. So it is represent the functionality of the another class, that is the outer, means this is real image class. Okay, so this is the real image. Okay, so you get it now. This is functionality. It will provide to it will represent the functionality of this class. Okay, real image. So file name is the string. Okay, so this is the functionality. This particular proxy class represent the functionality of this object. Okay, but this is the proxy image. So this is the display. So these are the functionality it will implement it and show in the particular interface. Okay, so this is the design pattern. So this is the proxy pattern. Okay, then, then we move toward the another pattern, that is chain of the responsibility pattern. Okay, chain of the responsibility pattern. So what they say? So as the name suggests, chain means the whatever the chain of the responsibility patterns create the chain of the receiver object. Okay, chain of the object for the request. Okay, so these patterns decouple sender and the receiver of the request based on the type of the request. Okay, so these patterns come under the behavioral patterns. Okay, so in behavioral patterns what we can say that the example of the behavior pattern. So this is here is okay. where we can say that this is the design behavior patterns means the communication between the two object. Okay, communication between the two object. So So this is the chain of responsibility. Responsibility means each and every object having its responsibility, okay, of the functioning. Okay, so the chain of the receiver object for the request. So this patterns is decouples under the sender and the receiver. Means the functionality or responsibility also be there depend upon each other. So we can say that it will be communicate with each other. Okay, these two means which two, sender and the receiver. Okay, sender and the receiver having some relationship. Okay, some relationship, and they are having the communication. So we can say that these patterns come under the behavioral pattern also. Okay, in these particular patterns normally each receiver contain reference to the other receiver. Okay, other receiver. So if one object is cannot be handled the request, then it passes the same to the next receiver and so on. Means here is the responsibility chain. Okay, responsibility chain means whenever you have to take any work, okay, you have to take any work from your teacher, but you can't be do, then you the pass to your friend. Okay, then friend is also be the append means this is the receiver. Nah, this is the receiver. So they say that this is the responsibility. So receiver get the responsibility or to pass it the some responsibility to the another receiver. Okay, to the next receiver. Okay, so on. Then we move toward the implementation. How it is implement. Okay, so we have to create it an abstract class. Okay, so this is the class what abstract logger with the level of the logging. Okay, then we have created three types of the logger. Okay, so the extending the abstract logger, so each logger checks the level of the message and its level prints accordingly, otherwise does not print the pass message to the next logger. Okay, so pass message to the next logger means the this is the passing the responsibility to the next receiver. Okay, passing the responsibility or the request to the next receiver. So we can see here is the demonstration. Okay, here is the demonstration. So what they say, here is the chain of the pattern. Okay, here is the chain of the patterns and this is the main functionality. Okay, so the first logger. Okay, first logger is the abstract logger. Okay, first logger is the abstract logger, and here is the number of the functionality, that is debug, then error, then uh, level, next logger. Okay, so these are the class. Okay, abstract logger is the class, and which divided these are the next responsibility, which are the console logger, error logger, and the file logger. Okay, so these are the, so whenever, yeah, we can say that any uh, so this is the chain na. So it will passes the message to the next logger. Okay. So these are the three logger. So any whatever the having any functionality message, it will transfer to the next logger. Okay. It will transfer to the next logger. So this is the functionality of the next logger. Okay. Next logger, that is abstract logger. Okay. Next logger, that is abstract logger means this is console logger. So next logger, okay, say the next logger, whatever the message, it will transfer to the next receiver. Okay, it will transfer to the next receiver. Okay, then we move toward the another design pattern. Okay, another design pattern, that is iterator pattern. Okay, iterator pattern. So iterator pattern is commonly used to design in the Java. Okay, So where it is used? It is used to design in the Java and .NET programming environment. Okay. So what they say, this pattern is used to get a way to access the element of the collection of the object in the sequential manner. Okay. How the collection of the object. Okay. Collection of object in the sequential manner. Okay, without any need know the underlying representation. Okay, so what they say, the iterator patterns fall under the behavioral pattern. Okay, why it is comes under the behavior patterns? Because the collection of object in sequential manner. Okay, so here is the number of the object and these objects are the related with each other. So we can say that here is the communication between the sender and the receiver. Okay, so we can say that the these can be sending the functionality to the receiver end also. Okay, so it is be comes under the behavior pattern category. Okay, so this is the iterator pattern. Okay, so what they say, these patterns is used to get the access the element of the collection of the object in the sequential manner. Okay, and we can say under the behavior patterns because here are the number of the object and these objects are the communicate with each other, or we can say that these are the uh, functionally dependent on each other. Okay, then implementation. Okay, so what is part in implementation? So implementation, they say that we are going to create the iterator interface. Okay, iterator interface means, so why the iterator interface is required? Because we have required the element of the collection of the object. Okay, the collection of the number of the objects, so we have required to create the interface. Okay, we have required to create the interface. So what they say, we have required the create the interface which narrate the navigation container interface and which return the iterator. So what they say that container interface. Okay, why the container interface? Because the object collection of object in the sequential manner. Okay, so it will be constitute. Okay, it will be conclude into the container. So the concrete classes implementing the container interface, it will be responsible to the implement the iterator interface and it use it. Okay, so what they say, it means also the concrete. Okay, concrete classes. Okay, so we have required the storing the container interface for this all the collection of the object. Okay, then iterator pattern demo. So this is the demonstration. Okay, so what is iterator pattern demo? Then the our demo classes, it will use as the names repository to concrete the classes inter implementation to print a, no, a name store as the collection names repository. Okay, so what they say, here are the number of the object. Okay, and these are the collected sequentially. Okay, these are the collected sequentially, so you can see it. Okay, you can see it. So this is the container. Okay, whatever it is, container. So this is the iterator pattern demo, and they can say that which object is create, it will be comes under the, it will be collect the sequentially. Okay, it will collect the sequentially, and for the collection we use the container interface container. Okay, so this is the container class. So whenever any new collection, so we can be stored in this particular class also. Okay, so this is name iterator, and these are the functionality. Okay, so get iterator. Okay, has next. Next means the sequentially, na? Sequentially. So this particular name iterator class also be the has next functionality. Okay, has next functionality and iterator. So this is the also be the main class, and these are the object we can be stored as the sequentially manner in the container interface. Okay, so this is the iterator pattern. Okay, this is the iterator pattern. Okay, then we move toward the our another design pattern. These are the mediator pattern. Okay, mediator pattern. So the mediator pattern is used to reduce the communication complexity. Okay, between the multiple classes or the object. Okay, so what they say, mediator. So this particular name you can be get from mediator because we can say the media. So why media? Media can get the use of information. Okay, use of information from the media also like news, whatever. Okay, so as per this particular mediator pattern is used to reduce the communication complexity between the multiple object or the classes. Okay, because these are the number of object. Okay, here is the number of classes. Are these classes are the functionally related with each other? Okay, so they say that this particular pattern, mediator pattern, reduce the complexity. Okay, which complexity? Communication complexity between multiple object or the classes. Okay, so this pattern provide the mediator class which normally handle all the communication between the different classes. Okay, so this is the main functionality. Okay, so what is the functionality of the mediator class? So it will handle the communication. It will handle the complexity of the communication between the different classes. Okay, and it will support easy maintenance to the code by lose the coupling also. Okay, so mediator patterns falls under the behavior patterns category. Okay, so why it is falls under the behavior category? Because here is the communication now. Here is the communication, so it will reduce the communication complexity. Okay, it will be reduce the communication complexity, so we can say that it will come under the behavioral pattern category. Okay, so then we move toward the implementation phase. Okay, implementation phase. So we are demonstrating the mediator pattern by example of the chat room. Okay, so they give the example of the chat room. Okay, so why? Because in chat room there are the number of object now. There are the number of object for the chat room, and they are the sending message to each other. Okay, so where is the multiple user can send the message to the chat room now, and it is the responsibility of the chat room to show the messages to all the users. Okay, so we have created the two classes. So this is the implementation or the demonstration. So they take the example of the chat room. Okay, why they take the example of the chat room? Because there is the multiple users. Okay, so the multiple users can be send the messages to the chat room. Okay, then we have created two classes. Okay, a chat room and the user having user objects. Okay, it will use the chat room method. Okay, to share their messages. Mediator pattern demo. Okay, so this is the demonstration. Our demo class will use the user object to the show the communication between them. Okay, so where is the communication? So this is the pattern. Okay, this is the pattern. So mediator pattern demo. Here are the number of the user. Okay, number of the users and name string. Okay, here is the only one the string, that is names. Okay, and this is the chat room. Okay, this is the chat room, means we can say that here is the functionality of the so these particular patterns reduce the complexity between communication. Okay, communication of the object. In chat room here is the no only one object na, no only one user also. So because in chat room here are the number of the user, they can send messages to each other. Okay, so this particular mediator pattern demo reduce the complexity between the communication of the object. Okay, communication of the object. So here is the object. Okay, here is the object. Because the users are the number of objects, so you can say that here is the number of the user. Okay, so this is the what we can say that mediator pattern. Okay, this is the mediator pattern demo. Then we move toward our another pattern. So I can say that it is the last pattern. Okay, uh, another pattern, this is the observer pattern. Okay, observer patterns. So from this particular word observer, what you can think? Okay, observer patterns is used when, okay, when it is used, so there is the one to many relationship between the object. Okay, one to many means the only one single user, and it whatever the only one server, and there are the number of the client. Okay, number of the client. So you can say that here is the relationship between one server and the number of the client. Okay, so they can say that uh, the observer pattern used when there is the one to many relationship between the object. Okay, such as if one object is modified. Okay, one object is modified, it dependent object are also be the notified automatically. Okay, so what they say, in particular relationship, one to many relationship, when one object is modified, it will notified automatically to the another object now, because these objects are the dependent on this modified object. Okay, so this particular patterns is comes under the behavioral patterns. Okay, so why it is comes under the behavior patterns? Because here is the communication. Okay, communication or the relationship. Okay, one to many relationship means the one server, number of the client. So you can say that the here are also be the communication between send server and the client also. Okay, so this is comes under the behavior patterns category. Okay, so in the implementation patterns. Okay, so what we have to say that here, in the implementation pattern, observer pattern uses. Okay, so this is the observer pattern. Now this is observer pattern uses the three actor classes. Okay, so subject, observer, and the client. Okay, so what are the classes? So subject is the object having method to attach and detach observer to the client object. Okay, so this is the subject. Okay, so what is subject? Subject is an object having the method to attach and detach observer to the client object. Okay, and then another one is the we have created an abstract class observer. Okay, so what they say, we have created the abstract class observer, and to create the class subject, that is the extending the class of observer. Okay, so what is the main? The observer class is the main, and another class are the client and the subject also. Okay, then the observer pattern demo. Okay, so this is the main class now, observer pattern. So our demo classes will be using the subject and the concrete class object. Okay, because we have required to show in one to many relationship. Okay, here is what they say, the observer pattern is only used in one to many relationship. Okay, only used in one to many relationship. So this is the demonstration design pattern of the observer pattern. Okay, so this is the observer pattern demo. Okay, so what they say that many to one. Okay, many to one. So this is the subject. Okay, this is the subject. This is the your observer class. Okay, this is your observer class, and this observer class having the number of the class also. Okay, that is the binary observer, octal observer, and the hexa observer. Okay, so this is the number of the object now, one two three, and the relationship to the one to many. Okay, one to many. So here is the extent from the observer classes. Okay, by using this observer classes, they use the what they can say that the relationship between the uh, many to one. Okay, relationship between the many to one classes. Okay, so they can say that whenever one object is modified, so it will be dependent object are also be the notified. Okay, so this is the uh, actually happens now. This is actually happens because whenever the this particular object is dependent upon the modified object, it will automatically notified. Okay, why automatically notified? Because it is functionally depend upon the modified object also. Okay, so this is your all design patterns. Okay, this is your all design patterns, and here is our unit number 4 is completed. Okay, get it? So this is your unit number 4, having the number of design pattern. Okay, number of design patterns or the types of design patterns. Here are the creational patterns. Okay, then another one is the structural patterns, and the last one is the behavioral patterns. Okay, because here are the 23 design patterns. Okay, 23, but our syllabus here are the some 7 to 8 design patterns only. Okay, so these 23 design patterns are the categorized or classified into the three category. Okay, that is creational, structural, and the behavioral patterns. Okay, so this is your unit number 4 is completed. Okay.